Woohoo! Welcome back. Today we're going to be talking about graphs of equations in two variables and intercepts. And in the book, this is in section 1.2. And you should know that section 1.2 is actually broken into two parts. The first part is intercepts and equations, lines, which is what we're going to be reviewing today. And the second part is talking about circles and symmetry and parabolas, which is all awesome, but it doesn't serve us right now. So I'm going to split that off and we will deal with that much later in the class. So let's come back to reviewing what intercepts are. Woohoo! So an intercept is a point where a graph intersects the x-axis or the y-axis. So if we have our, oh my goodness, kind of bendy, but let's pretend it's straight y-axis and x-axis like this. And I've got a graph, la 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 la. Then I can look at the graph and see that from where we are right now, we can see 3 points where the graph definitely intersects one of the axes. And remember that if we have one of them, it's called an axis. And if we have 2 or more, we have axes. And we tend to exaggerate it so it's easier to hear. So I've got 3 intercepts. These 2 intercepts right there are points on the x-axis, and so that makes it an x-intercept. And this one right here is, because it lies on the y-axis, it's a y-intercept. And you'll see that a lot of people simply write x-int and y-int for short. So expect to see either of those. Now the let me get this in frame. The x-intercept is the point or points when the graph intersects the x-axis. Ta-da! So the coordinates of these points will always be dun dun dun. So what is true about points that lie on the x-axis? You'll see these 2 points, they have different x values, but what's the y value? Exactly, y is 0. And so these will always have a coordinate of a, for some real number a, 0. So y equals 0. So a lot of people think of this as being kind of reversed, because when we're talking about an x-intercept, it is on the x-axis, and so y is the one that's 0. In the same way, the y-intercept is the point or points when the graph intersects the y-axis, like it did right there. And if you look right there, y could be a lot of things, but what's really important is that it's on the y-axis, so x is 0. So those are the important points to remember, that if we're looking for an x-intercept, we want y to be 0. So let me pull out my purple. The x-intercept, which are these 2 points up here, will give us y equals 0. And the y-intercept up here will give us x equals 0. So they're reversed. Okay, so let's go ahead and look at a problem where we can practice doing this. Woohoo! So for this particular problem, we're going to set up a table of values for this equation. Now, not everyone uses table of values. There are many ways to graph a line. You can graph a line using just the intercept and the slope. You can graph a line using well, my brain wants to say your friend's paper. No, not that way. You can graph a line setting up a table of values. You can graph a line by just plotting the intercepts. I mean, tons of different ways to graph a line. But we're going to go ahead and set up a table of values just for practice. So I've got X and Y. And this is the most basic table of values. Some people go fancy and they actually write in the entire y equals 2x minus 3. You're always welcome to do that. And the idea here is that we use the input-output method of coming up with ordered pairs. For example, if I want to know what happens when x equals 0, then y equals 2 times 0 minus 3, which is 0 minus 3, which is negative 3. And some people even like to extend the table of values far enough so that you actually include the ordered pair. You do not need to do this. But if you find this helpful, you're welcome to do this. This is intended as something you practice now, but then later on, it's maybe a method that helps you graph. The actual table of values could look just like this. 0, negative 3. A lot of people like to do the work in their head, so you wouldn't necessarily write it all down. So a wide range of options here. If someone asks you for a table of values, you definitely want to say, hey, how fancy do you want it? Now, for choosing other x values, everybody's got their own particular way they like to do it. I tend to like to step through whole numbers because I find it, once I try 0, definitely try x equals 0, and then I'm going to try 1. So y equals 2 times 1 minus 3 is 2 minus 3, which is negative 1. So we've got the point 1, negative 1, which would also look like that. And then I could go to 2, y equals 2 times 2 minus 3 equals... Sorry about that. Chai was helping me with the math. That was exciting. That's going to be 4 minus 3, which is 1. So I've got the ordered pair 2, 1. Pardon me. And you keep going, and you know yourself best. To graph a line, you need at least 2 points, but that's all. You don't have to graph more than 2 points. A lot of people like to look for 3 or more points just to be sure, a checkpoint, some other points, and some people just like a lot of points so it's easier to connect the dots. So it's totally up to you. You need at least 2 points, and we also have making sure to include the x-intercept and y-intercept. And here, let me remind you that the x-intercept is when y equals 0, and the y-intercept is when x equals 0. So we already have this one right here. This is the y-intercept right there. But we still need the x-intercept. So to find the x-intercept, we need to know what happens when y equals 0. And what I think I'm going to do is actually give myself a little bit more space with some white out here. I thought I was going to make a much bigger table of values, but I've decided, nah, I don't need that. So I need to find out what happens when y equals 0. Okay, so I've got y equals 0. 0 equals 2x minus 3. Add 3 to both sides. 3 equals 2x. 3 equals 2x, I can divide by 2. 3 halves equals x. So I've got the point 3 halves, 0. Now, a lot of people would look at this and go, oh no, I don't want to have to graph a fraction. And I'm going to show you how to avoid graphing a fraction. Sneaky, sneaky stuff. Okay, and this is our x-intercept. Oops, I was going to write x-axis. Isn't that silly? X-intercept, because y equals 0. So now I've got a bunch of points. 0, -3, 1, -1, 2, 1, 3 halves, 0. And again, since this is y equals 2x minus 3, it is linear because I've just got a y and I've just got an x. No x squareds, no y squareds, no square root of x, no x in the denominator. Nice and simple, which means we know we have a line. And if we know we have a line, you only need 2 points. And I've actually got 4. So excellent, excellent, excellent. So I'm going to go ahead and graph. Let's see. Ooh. I don't know if you hear that. There was just thunder on while I'm making this video. That was impressive. Woohoo. Okay, so I've got an axis right here. And I've got an axis right here. And again, when I'm graphing, when I'm asking you to graph, please identify your axes, label X and Y, label all the arrows, right? Get all the arrows on and make sure you label your scale. So I'm going to use a very simple scale where I just have ones. I'm counting by ones. And a lot of people look at a graph like this and goes, oh, do I have to use all the numbers? And the answer is no, you absolutely do not. You need to have at least one number on the y-axis and one number on the x-axis, and you're golden. Okay, so I think my window here is going to be a little small, but so I'm going to go ahead and copy all of my ordered pairs down so we can take a look at them without me moving the paper back and forth. So I'm going to start with 0, -3. That's right there. 1, -1. That's right there. 2, 1. Right there. And 3 halves, 0, which I don't want to graph, so I'm going to refuse to graph it. The good news is these all line up on a line. I'm so excited. If they do not line up on a line, that means you've made a mistake somewhere and you just need to go back and find your error. Or in a case where you're feeling frustrated because something's not working out, come talk to me, go talk to one of the tutors. We're all really happy to help you out. A lot of times, fresh eyes, someone who hasn't been doing the problem can look right at your work and say, oh, I see. You have 2 + 1 = 6 or something. So, okay, so I've got my graph, and now you're asking, but we didn't plot this point. And the answer is no, we didn't. But I know exactly where it is. It's right there. How do I know that? Well, that's the x-intercept. So you can skip graphing intercepts because you will be able to see where they are. Right here, this is our y-intercept, right? It's 0, -3. And right here is our x-intercept because it's where the line literally runs into the x-axis. And that's the point 3 halves, 0. Okay, so one more time. To graph for me, please include x and y. So you're labeling your axes. Arrows on the end of any sticks. You don't want anyone to get hurt. Arrows keep everyone from being hurt. And it reminds us all that this is just one small piece of a line that is infinite. It goes on forever. You need to put in your scale. That's what this is. The numbers here are scale. And this particular problem asked us to identify the x-intercept and the y-intercept, which we have. And we're golden. Woohoo! So I hope it's not thundering where you are unless you enjoy it, in which case I hope you're getting lots and lots of thunder. And otherwise, though, even if it's rainy, take a break, look outside, try to look at something green, turn off the computer and, do something that you enjoy. Know that you're awesome and that I want you to succeed, and I think you're amazing. So, woohoo, math on.